All right, Unit 11, the second day of this hodgepodge of a unit is Day 2, Function Operations and Compositions. All of the function operations we've been doing all year, so none of that stuff is new. Function compositions, though, is something brand new. So things to know for today's lesson, you're going to be combining two functions in different ways. F of x, g of x, and h of x are all just names of different functions. So what you need to know is the operations we'll use this lesson. If I have f of x plus f plus g of x, all it's wanting you to do is take function f and function g and add them together. F minus g would say function f and subtract from it function g. Fg would be multiply, and f over g would be division. And this is the exact same thing we did last unit, where you would factor, domain, and then cancel. So the only thing that's weird about this lesson is just kind of how each of the problems are set up. So examples 1 and 2. If I see up here, function f is 4x squared plus 11x minus 3, and function g is 6x plus 2, and then function h is x squared minus 9. So at the top of all of your homeworks, it'll name off those three functions, and then just give you a list of different operations to do. When I look at this first one, it's just wanting me to add f and g. So I'm going to take function f, which is 4x squared plus 11x minus 3, and I'm going to add to it g of x, which is 6x plus 2. Again, this is something you've seen all year. Combine like terms. My only like terms are 11x and 6x, and negative 3 and positive 2. So I have 4x squared. 11x plus 6x would be 17x, and negative 3 plus 2 would be negative 1. And that's my final answer. That's all they're wanting me to do there, is add the two functions together. For example 2, this is a subtraction problem. But this time they're wanting me to take function h, and here the order does matter. So I take x squared minus 9, and they want me to subtract function g from it. When you subtract, again, you're just combining like terms, but because I'm subtracting, I'm going to change this to an addition problem and just change all the signs inside the parentheses. So this will be x squared. There's nothing to combine with negative 6x, so that stays how it is. And then I have negative 9 and negative 2. So that's negative 11. So when I subtract those two functions together, it's x squared minus 6x minus 11. For examples 3 and 4, again, I'm using the exact same functions that they gave you at the top, but they're wanting me to, this first one is multiply. So this is where you do what you prefer, either FOIL or the box method, but they're wanting me to take 6x plus 2 and multiply it to x squared minus 9. If I FOIL this, that would be 6x to the third minus 54x. And that would be 2x squared minus 18. I don't have any like terms, so I just write it all in a row. 6x to the third plus 2x squared minus 54x minus 18. So that's what I get when I multiply those two functions together. For this last one, they're wanting me to take f and divide it by h. So function f is 4x squared plus 11x minus 3, and I'm dividing it by x squared minus 9. So my first step is to factor. I need two numbers that will multiply to negative 12 but add to 11. So that would be 12 and negative 1. So that side can't simplify, but this side is 1 over 3. So this will be x plus 3, 4x minus 1. X squared minus 9, that's a difference of two squares. So I have x plus 3 and x minus 3. So I notice the x plus 3's can cancel to leave me with 4x minus 1 all over x minus 3. And my domain is that x cannot equal positive 3 or negative 3. So again, that's exactly what we did the first day of the last unit. So those are all the different things we can do with our function operations. Now the function composition, this is what I was talking about, that something is new. What function composition is we're going to take one function and I'm going to put that inside of the other function. So I'm going to replace all the x values. I'm replacing it. I'm not writing it next to the x values. We're replacing all of the x values of the outside function with the inside function. So this is what it looks like. So f is the outside function and g is the inside function. So what they're literally telling you to do is to put the function g inside of function f. So you replace every x in the f function with the entire g function. For instance, I'm going to take g of x and I'm going to put that in place of the x. So I have 2, and then again, I'm replacing x with g. So it's going to be 3x minus 1. And there's nothing else to that function, so that's all there is. Once I put the one function inside the other, I can just distribute it through. And so f of g of x simplifies down to 6x minus 2. Okay. That should just say like example 5. Whoops. So we're just going to do one of these together. And then we'll talk about these more in class. So here my outside function is h. My inside function of g is x. So I'm going to replace this x with this whole function. So I'm going to take, instead of x squared, in place of x, I'm going to put 6x plus 2 squared minus 9. Now to simplify this, I have to remember that 6x plus 2 all squared means 6x plus 2 times 6x plus 2. So when I multiply that all together, I get 36x squared plus 24x plus 4, and then I bring down the minus 9. So my final answer is h of g of x equals 36x squared plus 24x minus 5. So you're trying your own. I'm not going to have you try the function composition on your own because I know that you guys will need more practice with me with that. But you do have these two functions, f of x equals x plus 2 and g of x equals x squared minus 4. And I want you to practice each of the 4 operations with those two functions. Good luck.